Ever wish your blockchain transactions could confirm instantly? With Flashblocks, they can. Pre-confirmations happen in under 200 milliseconds. In this video, we will see that speed in action, comparing Flashblock transactions with traditional ones side by side. If you're curious how Flashblocks actually work, there's a detailed explainer video linked in the info card above. Now, without any further ado, let's jump into it. So this is the app which we will see today. It's a simple Next.js TypeScript app which will help us visualize flash blocks versus traditional confirmations side by side. It's built using VM, WAGMI as well as RimboKit for blockchain connections. The main file or the page.tsx file is basically the entry point for any React app. So same goes here, where we are first rendering the header section which comes from the header component. Then there is this hero section, which is this section. Then comes the comparison panel, which is these two blocks over here along with these buttons. And then comes the CTA section where you can see a bunch of buttons over here, which is this section. And then finally is the footer section, which is this, where you can see this is the footer section with some text. Now let's go into components. So the most important component in our app is comparison panel. This file basically is the engine of our app. It wires the page with hooks. The main hooks over here are use transaction tracking and use balance tracker. We will look at each hook in detail, but first let's look at the comparison panel file. So first of all, we are basically importing all the necessary modules and components along with hooks. Then we are initializing the React component and checking if the wallet is connected or not using the WAGMI wallet connection hook. Then here's the transaction tracker hook. We will get into each function of the transaction tracker hook once we get into the hooks file. And then we are initializing two balance stores, one each for Flashblocks and Traditional. And then using React effects, we are updating the balance, one for Flashblocks and then another for traditional transaction. Then we are rendering the Flashblocks as well as traditional transaction metrics or confirmation metrics. Then basically we have the JSX rendering for this file, where first we have the connection reminder if the wallet is not connected, then the comparison grid for both types of transactions, then the control panel which will have two buttons, one to go to QuickNode faucet if you do not have testnet ETH, and the next button is to actually send the transaction if the wallet is connected, which we are checking over here. Then we have a reset button which only appears after the transaction has been sent. It resets everything to the initial state. Now let's look at our hooks, but before that let's look at a crucial file which is clients, where we are initializing two clients, one each for Flashblock and Traditional. For Flashblocks, we are using base Sepeaating pre-conf client, which auto uses pending tag as default for all the supported methods. And in the Traditional client, we are using base Sepeaating client, which uses the latest tag as default for all the methods. Now let's look at the hook files. So the first hook which we will look at is the balance tracker hook, where first we are importing the state hooks and address type from React and VM respectively. Then we are importing the Flashblock client and traditional client from the clients file which we just saw. Then we are narrowing down the client type so that only one can be passed at a time. Then there's a custom hook signature which depends on the address defined and client, and we are setting the states for balance and is loading. So this effect will run whenever there is a balance or address change. Then we fetch the initial balance for the defined client type and catch any errors if there are any. And this will kick off whenever there is an address or client change. Then we are exposing an imperative updater so that the transaction hook externally can use this and push fresh balance immediately after the receipt. So now let's look at the transaction tracking hook. Here again, we are importing a bunch of stuff from React, VM and WAGMI. Then we are importing the transaction tracker from types, which basically has pending and confirmed types. Then we are importing the demo config, which has the test amount set, which is 0.0001 ETH for our transactions, then importing both the clients. Here we are starting our custom hook. Then we have three pieces of states over here, one for Flashblocks tracker, another for traditional tracker, and one global. To enable or disable the send transaction button, it will be disabled while the transaction is sending, enabled while it's not. Then we pull the active wallet address and wallet client from WAGMI. Then we initialize the send transaction function, where we first check if there is no transaction in progress, if we have a valid address, and if wallet is connected or not, to prevent re-entry and check if there is a legit wallet connected or not. And once this will run, it will set the transaction progress to true. Then we actually send the transaction and set the timestamp as whatever the time is now. Then we initialize a tracker. Both will be using this. Then initialize the async tracker for Flashblocks on the Flashblock side, and same for the traditional transactions, and catch if there is any error in sending the transaction. Then this worker will monitor each side's transaction hash and write it in their own section. And this is the part which we will have to use in production. For example, right now we are polling for transactions manually, but if you want to apply this in production, you'll have to use wait for transaction receipt to get the transaction receipt. Over here we are setting the constants. We will only poll for 20 seconds at max, and this is where we are actually starting the polling loop. But first we are getting each block's full transactions for each client and then logging them respectively in console, and check if the transaction is included in that block or not. For Flashblocks it will be in the pending state, for your traditional block it will be latest. Then we are running a linear scan to check if the transaction exists or not. If the transaction exists, we log the time and then get details from the receipt like block number, status, gas used, etc. And over here we have the retrial logic, which will retry after every 100 milliseconds. And if no confirmation or receipt is found, it will log this transaction confirmation timed out. And here we will get the final transaction, update the balance, and update the trackers. Then we will write back to correct trackers so that the correct data for each side can be sent to UI. Then re-enable the transaction sending button. And this will be the logic for the reset button. Entire code will be linked in the description below. You will just have to clone it and do npm install or pnpm install. And then you will have to configure your QuickNode RPC URL over here and your wallet connect project ID over here. All the QuickNode base mainnet and Sepolia endpoints are pre-configured or already configured with Flashblocks, so that you do not have to do anything extra. You can start using your QuickNode RPC URL for Flashblock transactions or data. So I already have this server running over here. So let me connect my wallet. All right, my wallet is connected. Now let's send the transaction. So you can see the Flashbox transaction has already been completed in 0.540 seconds. It must have been confirmed even before that, but that's just our manual polling mechanism. And you can see the traditional transaction was confirmed or added into a traditional block in 2.021 seconds. So basically the thing is, this was a single transaction, same transaction, but it was added in Flashblocks pre-confirmation in this much time, and it was added in a traditional block in this much time. Now if we look at logs, you can see that the traditional checking block has started over here. Flashblock checking has started. You can see that the Flashblocks transaction was found over here and the object was written, but for traditional it kept on checking for 7 attempts, and after 7 attempts it finally found the transaction and logged the transaction object. So this shows how Flashblocks pre-confirmations work, where a same transaction was added into a Flashblock within milliseconds, whereas it took few seconds for it to get added into a traditional block. So hope this visual representation of Flashblocks versus traditional confirmations was helpful. If you want to learn more about Flashblocks and how they work, check out the video linked in the info button above. And I'll see you in the next one. Thank you.